Hey everyone, in this video we're going to look at some more challenging factoring problems. Push ourselves to see how good at factoring are we. Most of these examples look more complex, but we're still using the same factoring techniques. So it's all about identifying some key features to know how to factor it, and then go through the process of factoring. So let's look at a few examples to really understand what I meant. Directions: completely factor each of the following polynomials. First up, x plus 5 quantity cubed minus quantity x plus 5. So we have two terms, and the greatest common factor between those two terms is going to be x plus 5. We always look for that first. So we can factor out an x plus 5. Now from x plus 5 to the third is going to become x plus 5 to the second, and then minus 1. Right, think of x plus 5 cubed as x plus 5 multiplied by itself 3 times. We have 3 factors of x plus 5. And in the second term, we had 1 factor of x plus 5. So we took that 1 common factor of x plus 5 out. In the first term, that would still leave 2 factors of x plus 5, or x plus 5 squared. And then in the second term, it would leave 1. Now, if we look more closely here, we have the difference of two terms. So are the two terms perfect squares? Well, x plus 5 squared is a perfect square. 1 is a perfect square. So we could factor this using the difference of two squares. So we still have the x plus 5 factor. And then we're going to have x plus 5 minus 1 and x plus 5 plus 1 as our conjugate factors. Now we can go one step further to really clean up these factors. So we have x plus 5, and then we would have x plus 4 and x plus 6 as our other two factors. Okay, so here we have the factors of our original expression, x plus 5 to the third minus the quantity x plus 5. Next, we have 2x plus 1 quantity squared minus x minus 3 quantity squared. So there is no greatest common factor that we can take out, so we move to the next step. Do we see any other factoring techniques that we can use? Well, if we look at this as the difference of two terms, right, minus, so difference of two terms, what we should notice is that each of these terms is a perfect square, similar to the example that we just completed. So we can factor this with the difference of two squares. So we're going to have 2x plus 1 minus x minus 3. And then we will have 2x plus 1 plus x minus 3. Now we have to clean up our factors. So first thing we want to do is distribute that negative. So we're going to have 2x plus 1 minus x plus 3. And then we're going to have 2x plus 1 plus x minus 3. And we can combine like terms, so I'll change the brackets to parentheses, just so it's more familiar. So combining our like terms, the first factor is x plus 4. And the next factor is 3x minus 2. So as I was saying earlier, it's all about identifying what type of factoring we can use. Right? Other than that, it's paying attention to the little details with parentheses and signs, combining our like terms, and coming up with our final factors. But it's just the fact that the original expression, the original polynomial, looks more complex than what we've been dealing with before. Next up, 36x to the fourth minus the quantity y squared plus 10y plus 25. Okay, so this is an interesting one because it doesn't really look like much to start. But I do notice I have this trinomial in the parentheses, so maybe I can start with there. Maybe that'll change something. Well, I'd have 36x to the fourth minus, well, if we factor the trinomial in the parentheses, so we have 1 times 25, which is 25. So we need factors of 25 that add to 10. Well, that's 5 and 5. So we'd have y plus 5 times y plus 5. But let's write that more condensed. So let's write that as 36x to the fourth minus y plus 5 quantity squared. Well, that's interesting because now I have the difference of two terms. 36x to the fourth is a perfect square, and y plus 5 quantity squared is also a perfect square. So I can now factor this with the difference of two squares. So we'd have 6x squared minus y plus 5. And then we're going to have 6x squared plus y plus 5. I could have used brackets as the outer parentheses here. And now we can simplify if we want, just to make the factors look simpler. So we would distribute the negative 1. So we'd have 6x squared minus y minus 5. And here, because this is plus 1, we can just drop the parentheses. So 6x squared plus y plus 5. Okay, so that was an interesting one because from the start it didn't look like much other than this trinomial stood out. But then when we factored the trinomial and wrote it in a more condensed manner, then the key really popped out as the difference of two squares, and we proceeded from there. Okay, x squared times x squared minus 49 plus 7x times x squared minus 49 plus 12 times x squared minus 49. Well, if we treat this as three big terms, like so, well then x squared minus 49 is the greatest common factor in each of those. So we would have x squared minus 49, then times x squared plus 7x plus 12. And then we can factor x squared minus 49 with the difference of two squares, so x minus 7 times x plus 7. And then x squared plus 7x plus 12. Well, 1 times 12, so that's 12. So factors of 12 that add to 7 are 4 and 3. So x plus 4 times x plus 3. Okay, so we took a GCF out. We factored with the difference of two squares and trinomial factoring. So we had three different types of factoring in this one problem. Now, x to the 2n plus 5x to the n minus 24. So now they're just changing it because they're not telling us exactly what the exponents are, but they're telling us the relationship is 2n and n. And that's perfect because with this relationship in our terms, we can create factors that both start with x to the n. And the reason that works is if we do x to the n times x to the n, that would be n plus n, which is 2n. And when we go to distribute and get those middle terms, they're both going to be x to the n terms, which hopefully will combine to positive 5x to the n. So now we need to figure out the values that finish each factor. So 1 times negative 24 is negative 24. So we need factors of negative 24 that add to positive 5. So that would be positive 8 and negative 3. So we can go plus 8 minus 3. And then we're done. X to the n plus 8 times x to the n minus 3. If we distribute everything out, we would get our original polynomial. Let's do it. That's good practice. So x to the n times x to the n would be x to the n plus n, which is 2n. Then we'll have minus 3x to the n plus 8x to the n minus 24. So we have x to the 2n plus 5x to the n minus 24. Perfect. So let's use this same idea to factor x to the 2n plus 16x to the n plus 55. So we have x to the n and x to the n. Right? That leading coefficient is 1, it's prime. So guess and check, I think, is the best method, as it was in the previous example. So 1 times 55 is 55. We need factors of 55 that add to 16. So plus 11 and plus 5. And I'll leave this one for you to distribute out and verify. So that finishes the more complex factoring problems. Now let's transition to a different type of problem. Find all values of b for which the following trinomial is factorable. Okay, so we have x squared plus bx plus 9, and we want to know for what coefficient of x, essentially, what b value, can we actually factor this? Well, let's go through the process as if we were going to do grouping. So 1 times 9 is 9. So let's come up with all of the factor pairs of positive 9. So we have 1 and 9, we have 3 and 3, we have -1 and -9, -3 and -3. Now normally when we're doing grouping, we're looking for the factor pair that when combined can be used to replace the middle term. So if we don't know the middle term, what are the possible values that we can get by combining each of these factor pairs? Well, if we combine this factor pair, if we add the two factors, 1 plus 9 would be 10. 3 plus 3 would be 6. -1 plus -10 would be nope, got one step ahead of myself. -1 plus -9 is -10. And then -3, keep my arrow up, plus -3 is -6. So if B was any of these four values, okay, so B was equal to plus or minus 6 or plus or minus 10, we'd be able to factor it. Right, so let's just do one of them. I won't do all four out. Let's say I gave you x squared plus 6x plus 9. Okay, well, that would be x plus 3 times x plus 3. And you can verify this for the other three as well. You can practice your factoring. But essentially, we're building off the idea in reverse of using the grouping technique to factor trinomial. Right, and that idea of finding our factor pair that can be added together to get this middle term, and we're just figuring out what all the possibilities are. And those are the possibilities of B. Let's do this for one more example. Find all values of B for which the following trinomial is factorable, and now it's 2x squared plus bx minus 4. Again, let's proceed as if we were doing a grouping problem. So 2 times -4 is equal to -8. So we need the factor pairs of -8. So we have 1 and -8. We have 2 and -4. 4 and -2. 8 and -1. So if we combine each factor pair, what are the potential values that we could replace this middle term? Okay, so we'd have 1 plus -8, which is -7. 2 plus -4, which is -2. 4 plus -2, which is +2. And 8 plus -1 is +7. I don't think I did this in the last example, but basically right down here, this column is our B values. Right, so B could be plus or minus 2 or plus or minus 7. And again, let's do one example out. Let's say we had -7. Okay, so what would we do? We would list out all the factor pairs of -8 to find the factor pair that adds to -7x. So that would be 1 and -8. So let's do the grouping method in this case. So 2x squared plus x minus 8x minus 4. We can group the first two terms together, second two terms together, put that addition sign in between. Greatest common factor of the first two terms is x. We'd be left with 2x plus 1. Then we're going to have plus greatest common factor with the negative, because we need it to match 2x plus 1, is -4. And times 2x plus 1. Factor out that 2x plus 1. And then we have x minus 4. So that's just showing that -7 works, and you can show for +7, +2, and -2. But again, we're understanding the concept. When we're using the grouping technique to factor a trinomial, what are we doing? And this really exemplifies that understanding. We're finding all the factor pairs, finding their sum, and we're finding which factor pair sums to whatever value they gave us. In this case, they just want to know, what could they give you? What are the possibilities? Right, we saw one of them. In this case, there's 4 possibilities, 4 different trinomials that would factor using this same set of factor pairs. So, now that we covered the more complex, hopefully you're feeling really confident about factoring, but I would look at a few examples, right? They look complex, but see what you can figure out. See what you see, and then apply all your factoring techniques. It's great practice. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.